I mean, bacteria is everywhere. We're about 90% of us is bacteria. It's how we digest food and how our cells work. It's all bacteria. Bacteria can live without us, but we can't live without bacteria. There's some that's harmful, but most of it isn't. Most of it's beneficial. But it's in Yellowstone. It's much more evident. Look right above my head. That's an aerial photograph of a feature in Yellowstone Park called Grand Prismatic Spring. And that color, that orange and yellow and greens, is bacteria. Cyanobacteria, it's called. Cyan is blue, so none of it's blue. The blue in this photograph is actually clean water that's too hot for bacteria to grow. It's called cyanobacteria because the energy source for these little creatures is the blue spectrum of light. So that's called cyanobacteria. And there's literally thousands and thousands of species of bacteria that we know of in just these hot springs. And it's a friend of mine, Bruce Fouke, University of Illinois, professor. He's a microbiologist and a geologist, which is a kind of a cool combination. He combines these two disciplines. And he spent 25 years studying mammoth hot springs in Yellowstone Park. My favorite hot spring, my favorite thermal feature, because it's so dynamic. And he was studying the interaction between bacteria and rock. So bacteria creates the structure of the rock at Mammoth Hot Springs. And it's really amazing stuff. He was one of the people who decided where to land the Mars rover, because they're looking for life on Mars, and they figure if there's any life there, it probably was bacteria, because everything on Earth started from bacteria. We evolved from bacteria. And we don't know exactly where, probably deep water vents under the ocean, but we're not sure about that. But so they figure if driving this little rover around and they see any rock that looks sort of like Mammoth Hot Springs rock, there is or has been bacteria and life on Mars. Anyway, some really, really cool stuff. And he is now working with the Mayo Clinic in Minnesota on kidney stones. And kidney stones apparently are very painful, and they're calcium carbonate, travertine, calcite kind of rock. Grows in kidneys and is very painful to try to expel these kidney stones. Well, Bruce found out that they form the same way that rock forms in Yellowstone Park at Mammoth Hot Springs. So the idea is if you can figure out how they form, which bacteria create in certain people, which create these kidney stones, you can prevent them from forming. I mean, so Yellowstone and wilderness, I mean, Mammoth Hot Springs is a wilderness. That structure, that whole square mile plus complex of hot springs is wild country. It's right there. You can park and walk around on boardwalks, but we've left it alone, again, which is really important. We need to leave wild places alone. There's not much left, and because they become even more important. And then study them. I mean, you can learn a lot by studying a cornfield, but you can learn a lot more by studying a wild place, because there's so much more going on that we really have no idea. So what Bruce was doing was pure science. In other words, kind of scratch your head and say, what's going on here? And he spent 25 years, and some people would say, well, that's a waste of time. What's the immediate benefit? And there is no end game with what he was doing, which I love. Pure science is actually the most intriguing to me, because there's just, what's going on here? I don't know why, if it's important or if it's relevant to anything, but ultimately it's all important, because it's all what's going on in life around the globe, around the world, 2 miles down in the ocean, up in the stratosphere. We're all related. So the more we know about it, the better. And again, wild country is the laboratory with some of a selfish perspective, but that's where we can learn.